Hi, this is guided reading for Chapter 1, Lesson 3 called Convection and the Mantle. We're going to talk about how heat is transferred or moved from one source to the next and how convection occurs on Earth's mantle. That is the thick layer of the earth that is hard rock, metals, and all the materials that are solid underneath the crust. I'm going to skip lighting up the subject, compare and contrast section. I'm just going to read you the chapter. Please, you can follow along in your book. We're on chapter 18 or page 18, or you may read it independently in your book if you choose. How is heat transferred? Heat is constantly being transferred inside Earth and all around Earth's surface. That's how we stay warm, right? For example, the warm sun heats the cooler ground. In fact, heat always moves from a warmer object to a cooler object. That sounds pretty fair. They keep it balanced. When an object is heated, the particles that make up the object, they move faster. The faster moving particles have more energy. Think of an ice cube. There is nothing moving in there because it is frozen solid. There's nothing moving compared to a pot of boiling water where the whole thing is just moving and rumbling. That's a lot of energy in that hot water. Those are what we're comparing and talking about is that heat and the movement. The movement of energy from a warmer object to a cooler object is called heat transfer. There are three types of heat transfer. Radiation comes from the sun, convection currents, and conduction. Look at figure 1 to see examples of heat transfer. Please turn to page 19. So this guy's soaking up the sun with his radiation. Sun constantly transfers light and heat through the air, warming your skin. The transfer of energy that's carried in rays like light is radiation. We will talk about conduction. Put your feet in the sand. The sand's conducting heat. It's warming your feet. Hopefully it's not a super hot day because then it will be burning your feet. Conduction. Have you ever walked barefoot on hot sand? Your feet can feel as they are burning. That is because the sand transfers its heat to your skin. Heat transfer between materials that are touching is called conduction. Convection is seagulls often soar on warm air currents. The currents are created as warm air rises from the ground. The warm air heats cooler air above. Heat transfer by the movement of a fluid is called convection. That would be like boiling water. Nope, convection. Heat transfer by the movement of a fluid is called convection. We'll read further on that. You guys are not going to be responsible for this part. We may do a worksheet with it, but we're just reading through the chapter to get the basics. How does convection occur in Earth's mantle? Let's slide this over. I can actually zoom in a little bit so you guys can see it. Yeah, so convection is like boiling water. Recall the Earth's mantle and core are extremely hot. How is heat transferred from within the earth? We did our diagram of the earth and we had the earth like this, and the inside is a solid inner core of metal. The outer core is called the outer core. It's liquid iron and nickel, and that's hot lava. And then you have a very thick layer of mantle after that, which is your solid rock and minerals and all of your things that make up our big sphere of earth. So convection currents, when you heat soup on a stove, convection currents in the soup. Convection occurs in the soup. That is, the soup at the bottom of the pot gets hot and expands. As the soup expands, its density decreases. Density is a measure of how much mass there is in given volume of a substance. For example, most rock is more dense than water because a given volume of rock has more mass than the same volume of water. So when you think of dense, think of a bag full of rocks and a bag full of water. The bag full of rocks is a lot heavier and thicker to go through than just a bag of water. fish couldn't swim in a bag of rocks, but he could swim in a bag of water. So, you know, density is like how thick and heavy something is. The warm, less dense soup above the heat source moves upward and floats over the cooler air. So the warm heat rises up and it pushes this down. So that's why you get the rumbling in the pot when it boils. It goes up and over, up and over. And those are currents. That's actually also happening in our Earth's layers. So the inside red lava is boiling up and it's moving the cold rock. It's filtering it down and around. So that heat's moving. Near the surface, the warm soup cools, becoming denser. And then when it's heavy and dense, it goes down. Gravity then pulls the colder soup back down to the bottom. Here it is, reheated and rises again. A constant flow begins. Cooler, denser soup. This is going to be tricky. This is going to be on your quiz. Cooler, denser soup sinks, or cooler, denser fluid sinks to the bottom of the pot. At the same time, warmer, less dense soup rises. So if it's less dense, it goes up if it's warmer. In your bedroom, the heat rises and the cold air stays on the ground. The flow that transfers heat within a fluid is called a convection current. Here's a key fact. It's likely on the quiz. Heating and cooling of a fluid changes the fluid's density. The force of gravity combine to set convection currents in motion. So that's a lot of stuff to make that heat move like that. Without heat, convection currents eventually stop. So if you turn off your stove, your soup will cool down all on its own and stop boiling. On page 21, do we miss a page? 18, 19, okay, 19, 21. Convection currents in the earth. Inside earth, heat from the core of the mantle acts like the stove that heats the pot of soup. That is, large amounts of heat are transferred by convection currents within the core and mantle. Key fact, heat from the core and the mantle itself causes convection currents in the mantle. So the hot liquid here creates movement in here, and they have all of these convection currents. Remember, more dense, colder, less dense heat. And it's going to have you fill them in on here. That was on page 20. So if you have your workbook and you want to fill these in, please use page 20. Where was it on here? Right here. Less dense moves upward, and cooler, dense becomes the warmer soup. Gravity pulls the cold soup back down. So you can fill those in on there if you want to look back. To see how these currents work in the core and the mantle, look at figure 3, which is what we're looking at on the bottom of this page. How is it possible for the mantle rock to flow? Over millions of years ago, the great heat and pressure in the mantle has caused solid mantle rock to warm and flow very slowly. Many geologists think plumes of mantle rock rise slowly from the bottom of the mantle toward the top. The hot rock eventually cools and sinks back through the mantle. Over and over, the cycle of rising and sinking takes place. Convection currents like these have been moving inside Earth for more than 4 billion years. There are also convection currents in the outer core. These convection currents cause Earth's magnetic field. We talked about in the last chapter with the magnet and the filings. So there's movement in this, and there's movement in this. Remember, this is the liquid lava level. Page 22, and I'm pretty sure, oh, that's it. That's it for our chapter here. If you have your book and you'd like to fill these in, temperature B is hot. Temperature A is cool or cold. If you want to fill it in. Warm, less dense soup. Flows over the cold. The cooler, denser soup. So cool would be more dense. Cool is more dense. This is less dense. The rock, cooler air sinks. So this would sink. warmer air rises. So if you want to fill those in on there, you can do that. Thanks for listening. You can reference your book when you do your quiz tomorrow. We'll do the review section. There's a little couple sentences that'll be at the top of each question. Your quiz will be on Schoology. It'll auto-correct itself, so if you get the answer wrong, it'll just mark it wrong. But try your best, use your book, ask for help if you need it, and I look forward to seeing all of your hard work submitted. Thanks, guys.